Pode ser, Rogério? Okay. So good afternoon. Welcome, people. No, welcome everybody who is coming to listen to Carlos. Carlos, welcome to Rio de Janeiro. First time? Okay, so welcome. And so first of several times in the future, I hope. No. So today, Professor Alberto Reis is away. He's the organizer of the Colloquia of CBPF. And so he asked me to introduce Carlos because we invited Carlos and Alberto is away. And he asked me to take care of this colloquium today. And just to remind you, people asked me that this month we shall have 3 other colloquia on the 17th, 19th, and 20th. Because they are colloquia of people who were invited to teach, to lecture, to give seminars in the Brazilian School of Cosmology and Gravitation. So on the 17th, there is Gustavo Pazzini, who is going to talk quantum gravity, the unification of the microcosm with the macrocosm with microcosm. 19th, what are we learning about the universe from the astonishing pictures of the James Webb Telescope? Wayne Friedman from Chicago University, and on the 20th, Black Holes from Dawn to Glory, José Pizarro de Santos Lemes, it's our colleague in Portugal. So these are the 3 colloquia scheduled for this month. So Carlos is passing by here and very kindly offered the possibility of this colloquium. Carlos is professor at San Francisco State University, and he's a very good friend, he collaborator of a Brazilian who works there, José Acácio de Barros, who was Professor Francisco Doris here. He was Professor Francisco Doris' student in the past. Acácio, né, José? People here will call him Bolinha. He was his nickname. So Acácio is working in San Francisco too with Carlos, and through Carlos and Letícia, Professor Letícia Galuzzi from UFRJ, that Carlos got in touch with us. So Carlos, welcome. Carlos he has 2 PhDs, 1 PhD in philosophy in the United States, and the PhD in laws in Mexico City. No, UNAM. He has written books on psychological aspects of time, and today he's going to speak more on his field, which is philosophy. So philosophy of the foundations of physics. No, thank you so much, Carlos. So 50 minutes around, and afterwards open for discussions and comments, okay? Thank you so much.
Thank you, Leo, and it's very nice to be here. I've always wanted to be here, but finally I'm here. It's a great pleasure to meet all of you, and I hope that you enjoy this talk. It's a talk on various issues that touch on old questions about the foundations of physics and mathematics, but I will filter them. This is not necessarily a comment on this book that was just published, but I will filter a lot of these issues through this book that was just published called The Blind Spot, which is receiving some attention in the US. One of the authors is Brazilian, Marcelo Gleiser. So I will talk about that, and hopefully we will get a lot of questions from thinking about this. So, I mean, of course, there's many ways to understand the relationship between the mind, matter, and mathematics. One of them is very old, is a Platonic view, which apparently and amazingly is still extremely popular. But I will try to think through these issues through through a distinction that Paul Dirac introduced in a paper for a large audience in Scientific American. I know Elia Yale is a fan of Dirac, so I thought, why not do it through Dirac? Dirac is very clear about anything he says. So I will talk about 3 types of questions that he was interested in. One of them is about the consistency of current physics. By this, I think Dirac has in mind something like, do we have a coherent picture of all the different aspects of physics from the lowest to the highest scale? If not, how worried should we be? In this paper, in the Scientific American paper, he says that physicists should not worry about this, that only philosophers worry about this because they worry about everything. So he's not trying to be cynical. He thinks that of course, it's an important question. For example, whether quantum gravity is a possibility in the near future to have a consistent view of how that works. But I think he doesn't think these are the toughest difficulties in physics. Then he distinguishes this kind of question between, for example, the relationship between quantum mechanics or quantum field theories and general relativity from questions, he calls these questions class 1 difficulties. Class 2 difficulties concern the scope and limits of physics as a discipline. I ironically put current physical theory, it's really how current physical theory can be expanded. So the first type of question is, assuming we have a consistent set of views about the universe, how coherent this view is. Is it a view that makes sense to us or not? The second type of question is, can we expand it? And if we expand it, what are the limits of such expansion? Can we envision them or not? Then the third question is a question that he doesn't address in that paper. He says some other things in other places about this, but of course, this is a big topic for the founders of quantum mechanics, the relationship between, I say consciousness here, but it really is the mental, the relationship between mind and reality. And this was particularly pressing for the Copenhagen interpretation. In this book, the authors, a cosmologist, Adam Frank, Marcelo Gleiser, a physicist, again Brazilian, and Evan Thompson, a philosopher, phenomenologist, argue that there is a big problem with physics. It's actually, they think it's a big problem with science, but they really target physics. And the argument of the book is something like, since Galileo or something like that, some time after Galileo, there's been a constant systematic erasure of agency and the subject and human agency from the physical understanding of the world. And that has produced very good results, but it presents a problem in which there's several things they say. One of them is we have impoverished our understanding of several aspects of physical reality. We are confused about what our physical models really entail. And we are dehumanizing, this is the strongest thing I think they say, we are dehumanizing science and with consequences for the environment and so on by ignoring subjectivity. And one thing I'm going to focus today, the main focus of my talk, is to try to understand how those problems are the consequence of this issue they mentioned, the blind spot. I mean, again, the idea of the blind spot is that science, although science is based on concrete human experiences, the models of how the universe works completely erase human experience. So the question is, is that a single problem, or how is that problem related to a set of problems like those mentioned by Dirac? So the idea of a blind spot as a systematic and deep problem at the foundation of physics, I'm going to suggest might be inadequately posed. I'm not saying it's erroneous, but I think it would be more productive to think of it in a different way. And I'm going to mention a bunch of issues of why I think so. So this sort of blind spot issue can be understood, the way the authors understood it, it says that they say it concerns the act of measurement, it concerns our notion of time, the very idea that there's information in the universe that can be lost or not, that our models can be understood as in themselves having a reality that they shouldn't. So I'm going to go through all these problems. But the main idea is that it's difficult to think that once we think about all these problems, it is very hard to agree with the authors that it all depends on denying subjectivity. And I'm going to propose a few ways of reinserting subjectivity that would probably not be agreeable with the authors, but that I think are previous attempts to understand the role of human subjectivity in science. And one of them concerns the foundations of mathematics. Okay, so just to repeat a little bit, one reason, thinking through Dirac about this problem, the blind spot, one reason why it may not be a single problem is because of the different, this is philosophical jargon, the different metaphysical profile of the questions that we can ask about subjectivity. So one of them concerns the relation between subjectivity and what Dirac calls class 1 questions, current physics and its consistency. And then another issue is the relationship between class 2 questions about possible or future physics and the mind. That's independent of another problem, which is our current relationship between the material world, which is presumably invariant. It's not going to change with physical theory. But these three questions are completely different. I mean, you can, again, look at the metaphysical profile. One of them concerns actual physics. The other one concerns possible or future physics. And the other one, some sort of hypothesized relationship that should be invariant, but that we don't know how to articulate in either class 1 or class 2. So what the authors say in the text is that physicists are very confused about this. What I'm going to suggest is that the way they put it is confusing itself. I mean, we can see that these questions at the foundations of physics, first of all, are not ignored by many people that thought about the foundations of physics. And on the other hand, it's not a useful thing to say that subjectivity needs to be reinserted in physics. So I'm going to partly agree with the authors that aspects about rehumanizing science are important, but I'm going to say that they're of a completely different kind than foundational questions. Okay, so I hope that this is important for what I'm going to say, because it shows that if there is a problem with subjectivity, it's not a single kind of problem. As I said, the word that it gets used in the foundations of quantum mechanics is consciousness, but I think it's mentality more largely. Definitely, the authors have consciousness in mind when they talk about the blind spot. They don't think about mentality in general. They're not thinking about animals. They're thinking about conscious observers, the way the Copenhagen interpretation assumes. It's interesting that in philosophy, at least since Leibniz, the issue of mentality being at the foundations of physical reality is taken, for example, by Leibniz, but assumed by many other monists like Russell. And the authors of the book don't think that this is a way of reinserting subjectivity. So they don't think panpsychism is a good way to solve the blind spot. Right? So they think panpsychism is a way of understanding that there is a problem. They do think that it's a plausible view. They don't quite endorse it. But just to give an example, Gregory Chaitin also has the view that if you think that the universe is just information, then that is mathematical in nature, and there's a way of reconciling that with a kind of panpsychism. Is that a good way to reinsert subjectivity? I'm going to suggest that that's problematic for various reasons. Right? So if you think panpsychism is a way of reinserting subjectivity, then you're agreeing that everything is conscious. It's not just human subjectivity. Yeah? That's definitely what the Copenhagen interpretation assumed. The questions that Dirac was asking can be taken as constraints on the way we answer these questions, right? So one constraint on saying, for example, that everything is information could be that the change, and I'm going to quote Dirac about this in a second, the way in which we understand information changes a lot depending on our understanding of physical theory, but also our notion of observer and subjectivity. That is, I mean, or at least it's a question, an open question, whether that should remain invariant or not. And just saying that panpsychism is true, the view that all things in the universe rely on a consciousness, a fundamental kind of consciousness, is not going to resolve that issue. The difference between, for example, information in classical mechanics and quantum mechanics, and the transition between an observer and a measurement. So this is just a arbitrary way of thinking of this informational phase. I'm calling it informational phase transition because it's not, it's an informational interaction that is at stake in how we understand the subject, at least with respect to the notion of measurement. So one way of understanding this informational transition is that it doesn't involve consciousness. It involves something like an attentive observer, whatever that is, but not consciousness as such. And the idea here is that since measurements are publicly available, produce publicly available results, the act of measuring is something that shouldn't require something inaccessible from any point of view, such as the subjectivity of consciousness. Of course, there's the notion of qualia, the philosopher's notion of qualia, which is the irreducible subjective character of experience, which leads to the hard problem, which is why should anything physical, anything material, be accompanied by the very unique qualitative character of your experience. For example, when you taste the bitterness of a lemon, why should that accompany anything in your neural system? That's a different way of understanding subjectivity. It's very different from the first one because this one is radically private. It's not accessible to other observers. Another thing mentioned by the authors in the book is the important role of the body, of embodiment, and being in a particular scale. I've written about this with a neuroscientist. This is a very important aspect of the Bergson-Einstein debate, which is very interesting. Bergson was already a Nobel Prize winner when Einstein was when Einstein received or was postulated to receive his Nobel Award. And in their debate about the nature of time, they both keep accusing each other of misunderstanding the nature of time. And one thing that one impression one gets from the blind spot is that Einstein is insisting on ignoring subjectivity and that Bergson is insisting on keeping subjectivity in. But I think that's a bad way of looking at the debate. I think really what's happening is Bergson is thinking about time at the scale of living organisms and the importance of that for conscious awareness. Einstein is thinking about a different thing. So anyway, again, these are different ways of understanding subjectivity through the embodied view, through the hard problem of consciousness, through the notion of observation, not clear that they are the same problem. Unlike this problem, unlike the problem of what is the role of consciousness at the foundation of physics, material reality, in the foundations of mathematics, consciousness is clearly accepted to play an important role. So for example, our understanding of proofs is the metaphysical and logical foundation of mathematical possibility. Is our way back into the physical picture of the world to sort of create our path through the foundations of mathematics? That would be uncontroversial. But that is not really a blind spot. That is just the fact that mathematical necessity and possibility radically depend on metaphysical or physical possibility. Intuitionism is a traditional view in the foundation of mathematics. And there the view is that the conditions for mathematical necessity are a priori. And again, Kant, for example, says they're not only a priori, but they are necessary for all ways the world could be. Mathematics is going to be true if it's true. And what are the conditions for the possibility of mathematics? Our intuitions of mathematics. They're not, that's part of the Kantian system, that these are not conditions that we can measure or explore, or that the subjectivity needs to be reinserted in. That would be a very bad misunderstanding of the foundation of mathematics, according to Kant and a lot of the intuitionists. Again, this is not the only view about the foundation of mathematics, but there it almost doesn't even make sense to talk about a blind spot, right? Because it's by assumption, a priori, that the basis for mathematical necessity are given by the intuitions of a thinker. They're not measurable properties of anything. This is an interesting point also when thinking about Platonism in contemporary physics, or the view that all physical theory is reducible to information rather than matter, because a lot of what one can say about information, the space of possibility opened by how information relates to each other, if it's a priori, can be given by intuition. It doesn't need to be measured. I hope this becomes clear in a second, but the idea is here there is subjectivity at the foundation in a much clearer and a much more powerful way, and in a much more irrefutable way. But it's also not very helpful to understand how that could reflect that there's a big problem with contemporary physics. It's just a debate that seems orthogonal to the foundations of physics. Notice that this language, so this way of talking about physics as the view from nowhere, this is Thomas Nagel, as creating the blind spot, is also very different from what Kant thinks when it comes to conditions that are a priori. Okay, so one thing that comes up in the Einstein-Bergson debate, and this concerns views about mathematics, specifically about space and time by Kant and Poincaré. So for example, for Kant, the conditions for conceiving and determining possibilities in space and time are also given by intuition, whereas for Poincaré are empirical. They're based on basically conventions about measurement. But one interesting thing is that if they are given by subjectivity, then they should be scale invariant. That's definitely not the case for Poincaré, because scale depends on conventions about measurement and what measurements mean given a particular geometry. So even if one thinks, as the authors think, remember this is a cosmologist, a phenomenologist, and a physicist, that the one way of reinserting subjectivity is to reinsert phenomenology into physics. One faces this problem, that if you reinsert phenomenology into physics, one way of doing that is the way the foundations of mathematics are understood by Kant and Husserl. And if you do that, then your notion of scale invariance is going to look very different from inserting subjectivity in some other way. So I mean, we can go back to this a priori, a posteriori topic in a second, but let me move on. Okay, so that's just about the conscious, intuitive conditions for understanding physics and mathematics. What is the role of subjectivity there, and what is the relationship between that and the three class problems that Dirac is thinking about? One source of confusion might be that there is a conflation between consciousness and observation, and I pointed at that before. Observation is an act, and observation happens at a particular scale. It has consequences. And if consciousness, which is supposed to be private and fundamental and qualitative, is also foundational, it should also be scale invariant. Is that a constraint on inserting subjectivity? Well, it depends on whether one is a conventionalist about metric or an a priori person about metric, like Kant. In another interpretation of quantum mechanics, in the Copenhagen interpretation, and by the way, in the interpretation of quantum mechanics, it is not clear that the Copenhagen is the choice of the authors, right? It's just, oh yeah, consciousness is the thing that collapses the wave packet, and that's the happy way of doing physics. So in the many worlds interpretation, one problem concerning measurement and observers is that observers are supposed to be unique. There's a problem about how to count observers across possible worlds, how to insert subjectivity in the many world interpretation. You can think this is a problem for most interpretations of reinserting subjectivity into physics. And one issue that the authors keep mentioning is that the blind spot problem leads to over-formalization. I'm going to talk about this in a second because that's where they talk a lot about Husserl. And so they think partly because we don't know how to reinsert subjectivity into physics, and that causes many problems. For example, physics is not progressing. Physics hasn't developed much since the quantum revolution. It's also producing dehumanized kind of science, and is confusing us about the nature of physics, because physics shouldn't be equivalent to possible a priori models. With mathematical models, even though they're the result of our intuition, they're definitely the result of our conscious subjectivity, or at least we understand them through our conscious subjectivity. We understand also that they're not reality, right? And the point that you made through Husserl is, with physics, because we have removed subjectivity, we're confused about the nature of our physical models. They're just like mathematical models, but because it's clear that mathematical models depend on our understanding, we confuse with respect to mathematical models about quantum field theory or whatever. We're very confused about models that are supposed to reflect physical reality, because there's supposed to be like immediate correspondence with reality. And that confusion comes from removing subjectivity. And once we insert subjectivity into our models, then we see that they're just that, just models. And again, what I'm going to try to say here is that sounds good, but it depends on the flavor of question you're trying to ask. If it's current physics, if it's possible physics, is it a relationship between consciousness and matter, or is it the nature of understanding and conscious intuition? Those are completely different ways of understanding how subjectivity can be reinserted. Okay. So up to this point, what I'm trying to do is trying to understand what is the problem that the authors are trying to tackle, how to understand it. I've said a bunch of things. Some of the problems could be related to the very foundations of mathematics in relation to physics. Some of them could be related to general problems about measurement and how to understand the role of observation in physics. That's the first part. The second part is how physicists have understood some of these aspects that I've been talking about that are very important for the authors of the Blind Spot book. Okay. One huge issue that comes up all the time is the intelligibility of the world through mathematics and physics, the so almost magical efficacy of mathematics. And one interesting aspect about this issue is that people think that there's clear progress in our understanding of the world. So previous physical views concerned the macroscopic world. We started moving to a more mathematical interpretation. And as you move from primitive understanding of the universe to more sophisticated understandings of the universe, we seem to move from the macro scale and scales that are observable to not really unobservable scales, but mathematical models. Right? So we move more towards mathematics, and mathematics is what allows us to understand the real nature of the world. And you can see that in this. This is just a cartoon. For example, Ptolemaic model, the first mathematical understanding of matter by Galileo, which was a huge deal in philosophy of physics. And then now our understanding of physics as information in fields and probabilities. And with all these developments, you would think these are different kinds of understanding, but none of them tell you anything about what are the perspectives or possibilities of subjectivity in a universe that is changing in this way, right? And of course, here there are other perspectives that you can take. I'm not going to talk much about that, but I think this becomes much more complicated if you believe in the multiverse or the evolving universe. But this is just to illustrate the kind of issue that that comes up in how subjectivity matters in the development of physics as our understanding of the world. So like our understanding of the universe expands. And here, one thing that is interesting is that many of the physicists that thought a lot about this problem point towards beauty, which is very interesting for many reasons. But I'll just give one example. I mean, I'll cite Dirac. Dirac says something very strong about this. But the idea is the problem is not just our understanding, our relationship to the world, reinserting our subjectivity to the world, is also that our understanding of the world has a particular quality when it comes to understanding physics, which is that aesthetic understanding plays a very important role, or it's a guidance towards. That should be very confusing. I don't know if you think it's natural to say that. It's not natural to say that. And it's confusing because it says very little about subjectivity and it says very little about the world. It's just sort of like a guidance that the equations need to be beautiful, right? So let's go through these and see what's the relationship between this and the so-called blind spot, right? So in the Platonic understanding, I mean, there are many Platonists in mathematics, right? The Platonist thinks that mathematics is the foundation of all reality. Some people distinguish Platonists with a lower p and Platonists with a big P. Platonists with a big capital P think that that entails that the statement that mathematics is independent of any thinker, understandable by any thinker, and it's at the foundation of reality, that entails that mathematical objects exist in and of themselves. That's the standard view called Platonism. But Platonism, and some people say that that's really more Pythagoreanism, but many versions of Platonism also entail that beauty is at the foundation of the universe, right? So because the pure forms of Plato or the perfect elements are not only foundational, but the foundation of beauty in the universe. Hermann Weyl devotes a whole book, one of the last things he wrote. And Hermann Weyl was very interested in phenomenology. He was a student of Edmund Husserl. And he really upset Einstein when he wrote the preface to a beautiful book he wrote called Space, Mind, and Matter. Space, Time, and Matter, right? Space, Time, and Matter. I got confused with mind because in the preface to Space, Time, and Matter, Hermann Weyl says that the foundation of all space and time is our initial phenomenal conscious awareness of space and time. And Einstein was very unpleased by this. So this is someone who takes the blind spot problem very seriously. And in this book, Biles says that symmetry is a very important guiding principle to physical law, which is something that many physicists hold dear. And his explanation for this is that symmetry is imposed by mathematical simplicity. It's almost by epistemic necessity that symmetry plays this role in physics. And that beauty is based on symmetry, is of such nature that it provides immediate familiarity. This is very important for Biles. So that's why we find symmetric faces beautiful. We find symmetry in leaves and in nature. It's pervasive in nature. And this sense of familiarity is important for us to understand the beauty of the world guided by symmetry and physical principles. Again, this all sounds very a priori and very phenomenological. And again, this is someone who studies with the very founder of phenomenology. And it's interesting that, again, it doesn't sound like what the authors want when it comes to reinserting ourselves into the world as a solution to the blind spot, right? So, again, this is an invitation for thinking if this counts as reinserting subjectivity in physics. Some people might just say, well, that's just about how we understand mathematics and how mathematics is guided by symmetry. That's not a problem at the foundation of physics, right? Which is the claim here. The claim is physics hasn't progressed, physics has become dehumanized, physics has a lot of problems because there's this deeper problem that we are erasing subjectivity from physics. Okay, so now finally Dirac. These are two quotations, there are two citations from the, I think it's 1963 Scientific American essay. And notice this thing that Dirac says here. I mean, Dirac is not Biles, right? Dirac never wrote a book about beauty and symmetry. He never took classes with Edmund Husserl. He didn't care about phenomenology. He could not care about the notion of phenomenal bracketing and the epoche and the crisis of European sciences. And here's what he says in 1956. It is more important to have beauty in one's equations than to have them fit experiment. That's already super strong. And I don't even think Biles would agree with something that strong. If Schrödinger had been more, this is talking about Schrödinger's equation, if Schrödinger had been confident of his work, he could have published it some months earlier, and he could have published a more accurate equation. It seems that if one is working from the point of view of getting beauty in one's equations, and if one has really a sound insight, one is on a sure line of progress. If there is not complete agreement between the results of one's work and experiment, one should not allow oneself to be discouraged, to be too discouraged. That's the end of this passage. He seems to suggest not only that subjectivity is playing a very important role in understanding of physics, but that it plays a more important role than experiment. He also says sound insight. It's not just aesthetic beauty that matters here. But what is interesting is that beauty is playing an extremely important normative role. It tells you which equations should be the foundational ones. And again, there are better or worse approximations, and there are better or less degrees of beauty, but they're both not supposed to be subjectively dependent on a single observer, the way the blind spot is supposed to work, right? So the notion of beauty is not dependent on the single qualitative character of a single observer, and neither is whether there's agreement that the equations of a particular model are beautiful. Here's the second quote. I probably should speed up. This is 2 lines after the quote that I just read. this stuff about beauty is how quantum mechanics was discovered. It led to a drastic change in the physics picture of the world, the physicist picture of the world, perhaps the biggest that has yet taken place. This change comes from our having to give up the deterministic picture we're always taken for granted. We're led to a theory that does not predict with certainty what is going to happen, but gives us information only about probability of coherence of the occurrence of various events. This giving up of determinacy has been a very controversial subject, and some people did not like it at all. Einstein, in particular, never liked it. Because it's ugly? No. I mean, maybe some other reason, but it's interesting that there's this language of liking, not liking, supporting, not supporting, finding beauty or not finding beauty as foundational. Although Einstein was one of the great contributors to the development of quantum mechanics, he still was always rather hostile to the form that it took and it evolved into during his lifetime, and that still retains. Okay, so here you have two quotes from Dirac about this, and the idea that maybe just, I mean, Dirac doesn't put it this way, but one way of understanding this deep foundational issue is that subjectivity itself is not sufficient. You need something else. Beauty seems to be part of it, because beauty seems to be the ultimate guidance, the ultimate guide to whether something is truly foundational. So even taking into account articulations of how subjectivity plays a role in physics from physicists, it is not clear that just subjectivity itself is going to suffice. And I think that's important to keep in mind. Okay, so one question, very important, why didn't Einstein like quantum mechanics? He said things explicitly, not a lot of them very clear, but maybe it's unfamiliar, right? And familiarity matters for which theories should be endorsed. But again, the question of whether some equation is beautiful or not doesn't seem to be a uniquely subjective aspect about the equation. So there's this aspect about publicity that is playing a very important role in this discussion of beauty for both Weil and Dirac. It's important for them that this is publicly accessible. Everyone accepts that this is beautiful. And yes, it depends on our understanding. It depends on how we think about the universe, but it's not my private consciousness that matters here. Is the fact that it is beautiful. It is a fundamental aspect of the equation. I'm going to skip this. And so after going through these iterations of how to reinsert subjectivity, it seems that it cannot be just doing mathematics differently. That's just not, that doesn't seem to be a way of reinserting subjectivity. The point that physical models are taken at face value as if they were reality, for example, in the many worlds interpretation, is well taken. But here again, what is important is how we understand these models. And even if we're told that we are confused in thinking that the models are real, we still need to understand what makes them successful or beautiful or not. And that's not going to be a subjective aspect of the model. Or it's not a subjective aspect of the model, but an aspect of the model that depends on our subjectivity. I think the authors are right that Husserl is correct in thinking that methods in physics should not be taken for reality and hypostatization. But that issue could be solved through a way of understanding the foundations of physics through our subjective capacities as a kind of joint attention rather than inner conscious awareness that is exclusive to the thinker. And so that's the suggestion that I'm going to develop now and then finish because so one thing that I think is that there's philosophers of physics that think that doing physics is always from a perspective, but no one really thinks that this perspective is completely subjective and unique. It's just that the perspective of the thinker matters to whether the model should be understood one way or the other. Just to give you examples of people that are constructivist and think that personal components of models should be very important for understanding models. They have Basman Frazen, Ronald Geary, and Michael Polanyi. One suggestion is that the blind spot is not really a problem in physics, but in philosophy and psychology. Right? And of course, the authors would say, well, yeah, it's a problem in psychology because it's about subjectivity. But a problem about subjectivity and how to interpret physics need not have the consequence that they think. Right? That it's physics that is deeply limited and incorrect. If the blind spot is the hard problem, this problem about why should your conscious awareness accompany any physical material firing of neurons in your brain, then no one thinks that the hard problem is a problem for physics. It's a problem for everyone. It's a problem for the materialist view of the world, not for physics as such. Is it a problem about the self in general? That would be even worse, right? Because the problem of the self is a metaphysical problem. It's not even a psychological problem. So to conclude, the blind spots may be thought about in different ways. It's a good beginning to start talking about different limitations of physics, but it may not be a very productive way of thinking about how to move forward. You can ask sociological questions about the research culture in physics, whether it's really ignoring aspects of subjectivity systematically or not, how to think about transitional or revolutionary science, the way Thomas Kuhn thought, whether that depends on transitions in our understanding, the way Dirac thinks, that depend on things like the beauty of a model. But all these questions have been asked and addressed before. An alternative is not just that the blind spot problem is not really a problem in physics. Could be a problem in the foundations of mathematics and how we understand physics through that. But an alternative view is that it's an ethical problem, that physics has become militarized, dehumanized, supported by governments with particular interests, that it ignores the interests of humanity. All that is very legitimate and valid. It's a valid criticism, but it's not a problem in physics. It's an ethical problem. And it should worry physicists, but it shouldn't worry physicists as a foundational problem concerning their discipline, right? So just other thoughts. This is the relevant one. They keep talking about sobering knowledge through a reenchantment of science. And again, this could be interpreted as, yeah, let's do what Leibniz and Spinoza were doing. If the problem really is the unethical character of science, then that's not really a foundational problem. I mean, it is a big problem, but it's not foundational. And finally, what I suggest is that the notion of subjectivity needs to be more nuanced in thinking about the blind spot. So one thing is the nature of consciousness, another thing is the nature of attention. I think what physicists do for most of the time is something like joint attention to particular models with particular consequences and particular ways of measuring outcomes. And there's a way of understanding that and making sense of beauty as a guiding principle. And Catherine Elgin has written about this as epistemic gatekeeping. So the most beautiful models are the ones that explain the most. Right? So that's partly what makes them beautiful. And they're the ones that allow us to pay attention to more consequences at once. Okay, I'm going to move forward because and this is one of the last things I want to say, that joint attention is very important in science. And thinking about the blind spot as a problem of subjectivity seems to deny this. And I find that a little bit problematic, at least something to think about. Modeling is also problematic because models are a way of jointly paying attention to features of reality, independently of our subjectivity. So it's very hard to see what the single error is here. There's just a variety of problems, a variety of ways of thinking about the mind in relation to physics and the conditions for the possibility of physics. And it seems that a more productive debate would be not to go back to what Boyle and Dirac said about this, but to look at what we can say now with contemporary psychology to try to understand the so-called blind spot. I think this is a little bit repetitive. I mean, one thing that is important is that our position in the world is not the same as my subjective position in the world. And that reasserting subjectivity is not going to be immediately informative about which exact physical model is valid or invalid. So this is, I think, sort of a way of encouraging people to think about the blind spot in a way that involves several problems and not a single difficulty. Although I do this because I'm deeply sympathetic with the book, and I recommend the book. It's very good, The Blind Spot. But I think because of the reasons that I gave, it involves a variety of difficulties, all of which are independent of each other and require independent treatment. Thank you.
Okay, so now we are open to questions, comments, suggestions. So, okay, Chico.
Thank you for your lecture. I would like to ask you what you think and what the book says about the problem that you mentioned. Since the quantum revolution, no real progress, etc. But it was, as you in one of your slides list the descriptions, the levels of descriptions of reality, the final fundamental levels of probabilities information was inserted in the quantum revolution. And it's at this level that subjectivity is kind of inserted in our descriptions of the world. So how do they describe or discuss how this insertion of subjectivity is kind of masked nowadays by this science that claims that's not subjective at all and try to ignore or have this blind spot with subjectivity? Because there is a blind spot in the sense that there is no agreement in what the subjectivity measurement in quantum mechanics plays a role. But it's not a blind spot, it's discussed, it's widely discussed. So how do they, because for me the problem is that there is subjectivity. So how do they combine these two apparently paradoxical facts?
Take here, Carlos. Here it is.
Yes. Yeah, I mean, that kind of question is the sort of thing that got me going here with these other questions. So they think that the debate in the foundation of quantum mechanics reveals that subjectivity is very important, but that it was quickly ignored, so that a pragmatic approach was taken, right? So sort of the way I was explaining this is just I don't know who exactly said this. Apparently, it was Feynman. Just shut up and calculate, right? And the idea is ignoring the foundation of physics that way just makes the problem worse because quantum mechanics revealed that subjectivity is playing this important role. But this thing that I try to say here is, well, it could play a role in very different ways, right? In every interpretation, there's something that happens with subjectivity, and subjectivity is the problem in the first place. And so the lesson shouldn't be that we need to reinsert subjectivity the way they think. But I'm going to give you an example that they give just because you also ask, what do they say in the book? That's very important. But that's why I think reinserting subjectivity doesn't make a lot of sense if the project is to think physics in a way that is connected to our conscious awareness. Partly because conscious awareness is a private phenomenal thing. It's not publicly available thing. That's why I said these things about joint attention at the end. One way you can understand the ethical point they're trying to make is that only a select group of specialists can pay attention and generate knowledge of the physical world with the exclusion of the entire humanity, right? And that's dehumanizing science. You can make that point from an ethical point of view and say we need new systems of attention, new systems of education, without appealing to inner subjectivity. But what they say about time, and I want to talk about time because this is something I've been working on, is that by denying the nature of the subjective character of the passage of time, science has ignored life, or physics has ignored life as an important constraint on the universe, right? Some physicists think that life, I mean, this is independently of the anthropic principle, that life is an important constraint on the evolution of matter or whatever. But their claim is much stronger. Their claim is physicists are ignoring the subjective dimension of time, and that's costing us at the theoretical level. And again, there, I think also, well, it depends because you can understand embodiment the way Bergson thought about it in terms of life, at the scale of life, and not make it exclusively dependent on phenomenology. So I think what is unique about their view is that they're really taking Husserl very seriously in the with the idea that science is a conventional, not really primitive imposition on our experience of the world, that our experience of the world justifies science in a way that science cannot justify itself. And again, that is not, even if that's true, that's not really a problem within physics. It's a problem of how we understand our experience. So I hope that helps. But I mean, what I want to say is that the criticism of physics is legitimate, I think, but the solution of reinserting subjectivity is what I find very puzzling.
Anyone else? Oh, Felipe.
Hi, thanks for the talk. So I'm trying to understand how far they go with this subjectivity issue. So one of the common, at least as a working hypothesis physicists do, it's that nature has a objective, unique reality, right? So I'm trying to understand is if they ignore, or what is the nature of reality for them, or if you include subjectivity, do you have to give up on this idea of unique reality, objectivity of the reality, or how it goes? Or it's just a matter of the physics, the theory that it has to be subjective and not the reality itself.
So, can you hear me?
Yeah,
Yes.
yeah.
Okay. So about this specific question, they say that they again take Husserl, and what they say is physics is reifies models into reality. And that has confused everyone, right? That has confused physics, the physics community, that has confused us into the materialist view. And then they make the much stronger claim that that's because physics has decided to erase objectivity from the foundations of physics. I think you can do against the materialist view, you can take someone like Max Tegmark, right? So who says the nature of physics is information, and we learned that lesson like sort of like from quantum mechanics onwards. And if you think that it's a bunch of fields with probabilities, then it's very hard to think of it as an independent reality that is always there. But that has nothing to do with subjectivity. So I think one aspect of the criticism is valid. The reinserting subjectivity aspect is what I don't understand. So, but specifically what they say about your question is the material view or the idea that physics deals with objective reality is the result of a mistake. Is the result of thinking of physics as a realm of access to reality that is completely and absolutely independent of thinkers and observers.
So basically, they argue that we have to give up on the idea of unique reality. Basically, they go that far.
They definitely go that far. Yeah, okay. I think they go further than that, because I think a lot of physicists I mean, here it depends on what we mean by physical reality and just reality. Because if you think that the universe is mathematically structured and that it involves possible mathematical structures, then what we call physical reality at our scale is not reality, right? So I think that criticism is more nuanced than the subjectivity. But what is important to clarify about your question is that the way they deny that claim that physics gives us access to ultimate reality is by means of subjectivity. So they definitely do that.
Okay, thank you.
Yeah.
Someone else? If not, Chico again. Okay, just a moment, Chico.
Hello, thank you for the talk. I'm sorry I came a bit late, so I don't know the whole aspect of the lecture. But in regards to subjectivity, I think there may be two kinds of subjectivity. One is perceptual subjectivity. For example, the same blue I can see in an object is not exactly the same blue you can perceive on the same object. So there's some intransferability of the senses, of the immediate senses that we experience in our everyday world. Do you know if there's some line of research that involves, I don't know, maybe semiotics in trying to understand these perceptual subjectivity?
Yeah, the hard problem is sort of a formulation of what you said, but it's stronger than semiotics because the idea there is that your experience of blue is unique to you, only accessible to you, and is completely independent of material events happening in your body. Right? It's in the sense that even if there's causal relations, they're not explanatory of the experience. Right? You cannot say, I'm having this experience because I'm in this physical state. The physical state has nothing that explains the qualitative character of your experience. And this is supposed to be a really radical problem for science in general. And again, what I want to say about that is that if that's the blind spot, that's a problem for everyone. That's not just a problem for physics. And it's a problem for everyone in a way that it has been discussed. It's a denial of materialism. It's an invitation to panpsychism. And the authors are not really trying to do that. They're trying to say, no, this is a problem that we have in physics, and it's a problem that has to do with how physics denies its rootedness in experience, something like that. So, but the most radical version of the problem you as you postulated it is the hard problem, David Chalmers. Yeah.
Thank you.
Philippe came late because he was just presenting his master thesis.
Oh, thank
He's
you
a
for
new
giving me.
master. Very,
Congratulations.
very fresh. Then half an hour ago, he became a master. No, okay. Congratulations. Who else? Who else? I know that Chico is okay. Register after. Is there anyone? If not, Chico, with your wrong question.
Just because you said that they critique the reification of mathematical models. But what also happens in this period after quantum revolution is that physicists embrace the idea that these mathematical models are predictions of experiments, and they do not need to be reified in the sense that they describe independent reality. So quantum field theory is a theory of S matrix and probabilities and things that not necessarily describe an independent reality. That's we can't describe a hydrogen atom with quantum field theory, but we say that the foundations of reality are described by quantum field theory. So I don't see how it is a problem that I think we should try to find models that we can try to reify. That's not what we have today. So I think most theoretical physicists would say we don't reify our models. We don't think of these things as real things. We think we make calculations, we make predictions, we go to experiments, we corroborate our predictions. So that's how physics works nowadays. So I don't get, I know that sometimes seems to the public that we try to do that because we use a lot of analogies, but in general, I think the real problem is that we don't have mathematical models that are reifiable, that are related to material reality. So I don't understand, because the problem of physics, theoretical physics nowadays, for me is more in that direction than the opposite direction, that we should not have reification of models. We should embrace abstract mathematics. So.
Yeah, I mean, so in fairness, I mean, maybe I just presented the view very simplistically, but in fairness to them, they really care about this. So maybe I can find this because it's where they talk about this. Okay. Well, it doesn't matter. But when they talk about Husserl, they say it's a methodological. It's in the character of physics to methodologically postulate things that are taken as ultimately real. So even if there's no agreement, that's the ultimate task, that we will find those things. And they think that's a deep epistemic misunderstanding of the role of science, because what science should be doing is clarifying how this understanding depends on our experience and relocating ourselves in our understanding of the world. Now, this second claim, I think what is interesting is it has a valid ethical point, but that ethical point gets confused if it's interpreted the way you were doing, right? So if the claim is we need our experience to be part of the models, and no model can be really postulated as such unless it's understood as our way of experiencing, then I think that's not a good way to go. They don't really present a very clear path. They document a series of problems, but I think their main point is the methodology of physics is a systematic erasure of subjectivity, and that has these bad ethical consequences, has these bad consequences that are epistemic, that we think that the models are absolute and comprehensive, and we need to sort of identify where we can redo physics in a way that is rehumanized or re-enchanted. And so what I try to do is, yes, you can do that in many ways. You can do that through the foundation of mathematics. You can do that through principles that have nothing to do with the models as absolute reality. So you talk about symmetric principles. You talk about, by the way, that book by Herman Bailey is amazing on symmetry. And he turned out to be very right about a lot of things. I mean, symmetry in physics is very important. So there's the quotation from Dirac, right? So these are not just models, absolute models. We're guided by subjective aspects, such as understanding that this is a beautiful equation. And the reason why I cited Dirac is that Dirac's not taken, I mean, he's not famous for saying something very strongly the way Herman Bayle said it about symmetry. I think Herman Bayle is very relevant because precisely because of this preface he wrote for the Space, Time, and Matter book, where he literally says the foundation of cosmology is our experience of space and time, not really invoking Kant, not our pure intuitions of space and time. He disagreed with Kant, but our experience, right? So it's very relevant that Bayle didn't say we need to reinsert ourselves full force as subjectively aware individuals. What we need is principles like, beauty, or understanding that phenomenology is at the foundation, but that's not a problem in physics. That's a way of understanding more philosophical aspects of our situation in the world. But what I like about the Dirac quote is that he says something very strong. He says, even against experiment, we should trust our judgment of beauty as a guiding principle, right? So again, it's not clear what exactly would please the authors as like reinserting subjectivity, but there's clearly things that have been offered, and none of them seem to suggest, yeah, this is a very deep problem within physics. So maybe the problem is we need to rethink the ethical question as independent from the experience question, as independent from the epistemic question of how physics has become out of touch with the public, or whatever is the problem there. And these are, that's the main point I wanted to make. These are very different topics. They're all important, but it's not a single problem.
Okay, someone else?
Hello, thanks for the talk. I think I could understand more or less the point the authors of the book were trying to make, but I don't think I quite understood your point exactly. So you would say that you said that the authors of the book think that there's a problem. You said there are multiple problems, not all interconnected. So you would say that modern or contemporary physics doesn't present clearly a foundational problem relating to a foundational epistemological problem, for example. That would be your position. There is not a very clear, unique epistemological problem in modern physics. That would be your position against this more vague position of the author of the book. That's what you're trying to say, more or less?
Yeah, yes. And that, for example, they do have an emphasis on how science and physics in particular have become dehumanized. I think they have, I mean, they say things about being militarized too, but I mean, I think that's definitely a very separate problem from the epistemic problem. Yeah.
Okay, thanks.
And just to clarify a little bit, thanks for the question, because that allows me to explain something I wanted to say too about this problem. If you think, well, let's really go for it, and let's reinsert the subject as strongly as possible. One way of doing that is to be an intuitionist about science, and sort of like be Kantian about science, right? So just say the foundations of all possible models of physics are based on our intuitions of space and time and mathematics. That delineates the space of possible worlds and possible theories. What we are doing when we are transitioning from one model to another, like classical to quantum, is readjusting the parameters of our principles, making them relative to conventions, right? But those conventions are also our conventions, and they're also depend on our experiences. and our intuitions, right? The reason why I don't think that would please the authors is because that's a very important view in the history of philosophy. They could just say, let's go back to Kant, right? But they don't do that. It's my point is a little bit stronger than just saying these are different problems, is that these are different problems for a good reason. Because if you think that there's a single problem and that the problem gets solved by reinserting subjectivity, it's very unclear that you will be doing physics by just thinking about experience, right? So you will need to do something that has been tried before. Just doing phenomenology the way Husserl did it, which even Hermann Weyl said, yeah, that's not physics, that's foundational epistemology, right? Or you need to do Kantian stuff, or you go back to the Leibniz-Clark correspondence. Is space and time something we investigate empirically, or are the conditions given a priori subjectively? You're doing the traditional business of the epistemology of geometry, but you're not really reinserting subjectivity. That's kind of what I wanted to.
Another question. So actually, I have several questions, but I'll keep. So I'll probably make a question more like a science studies question point of view. So when they say we are dehumanizing the physics, so we can move back, and so moving towards the past, it's humanizing. So it looks like a romantic move here. So like the past is much better, is wonderful. And also, it's almost like an invitation to put gods in physics. Like you cannot understand nature without God or whatever, like, right? And one last point is that, do they criticize capitalism like economics? Because that's really dehumanized, right? And that's exactly what's destroying nature and not specifically physics. So my question is, do you think this is a movement that's it's growing in the US, and how big it is, and could be like our times that's very strange nowadays? I mean, yeah.
I find it, sorry. I find it very interesting that, I mean, first of all, I do think that it sounds romantic. And I think one of the dangers is that when, and again, this is something that has been tried before. One of the dangers here is that re-enchanting nature, this is a term that is used by some philosophers, really is sort of like trying to recreate, I don't know, ancient Greece or something like that, where everything is meaningful and everything is connected to beauty, everything. I mean, one thing I wanted to do with the Dirac quote is like, here's someone who is not really thinking about re-enchanting anything and is still thinking about beauty and is not really concerned with a deep problem in physics, right? So I think what is a movement in the US is that more and more people, I don't think this is just in the US, but more and more people think that physics is stuck in a bad plateau of creativity because there's a problem that is deeper than just coming up with physical models. That there's something that happens either with the culture within physics or with a specific way of thinking about the methods of physics as ultra specialized, semi and absolute ways of understanding reality that has made them completely detached from human values, right? And then they add, it's dehumanized because they don't really think about capitalism, but it's been dehumanized because it's been militarized, right? I don't think that's part of what's happening, but a lot of people think, yeah, physics has, for example, the criticism against the string theorist, right, has postulated theories that are mathematically consistent and solve mathematical problems, but they have imposed that as a method that has replaced experimentation and traditional ways of doing physics. So the idea is there's a set of issues happening in the US. One of them is the culture in physics seems to be not conducive to new breakthroughs, which is very important because the last big breakthrough is 100 years old. Another set of issues is there's something wrong with the culture in physics because specific ways of doing Platonized physics as mathematical abstract models have dominated particle physics. So that's a little bit more specific than the other one. And then this other claim about dehumanization and devalorization, I don't think that's a big movement. It's just sort of one school of philosophy of science, like Bruno Latour, for example, talks about this, is that we have, he makes almost the opposite place. He thinks that we have made science so detached from living systems that it has become this, I mean, what his criticism is really about capitalism. So these are three separate questions. I think they are behind what they're talking about, but I don't think it's a movement. I think the risk about how they put it is that you would think there's something intrinsically wrong, intrinsically wrong with the way physics is done. And I think there are bad things about how physics is done, but some of them have to do with society at large.
Yes.
Some of them have to do with the culture within physics. They're not the same as problems of subjectivity. But I do think there's some anxiety and concern about what exactly is happening that physics is in this situation. Of course, that's not what a lot of people think, but
yeah,
this is what I...
And it's funny that because two of the authors are from cosmology and astrophysics, and we have like a huge breakthroughs in the last 50 years. So it's amazing how they ignore their own area, but it's own field, but okay. Thanks a lot.
So someone else? Okay, Philippe again. Okay, the new master.
In physics, we already have some subjectivity that's encrypted in the capacity to formulate axioms and postulates. Could you talk a bit about that?
Yeah, that's what I try to capture with the Kantian stuff, because so I mean, actually, this is a good slide for that, because the Kantian view is some models have to be validated empirically through observation or whatever, but what gives the set of possible models is our pure intuition of mathematics and space and time. And the idea there is those are completely, that's why Kant's system is called transcendental idealism, because it's through the conditions of subjectivity that you articulate the axioms that then govern physical law and everything else. I think that's definitely not what these guys have in mind with reinserting subjectivity. I mean, if you read I mean, again, maybe I'm not being very charitable here, but if you read the book, they have one problem after the other: cosmology, time, space, you know, the foundations of quantum mechanics, as if they're just manifestations of a systematic error in the methods of physics to erase subjectivity. That's the very strong impression you get from the book. Actually, this thing that I quote at the beginning is the very description they give. Science is based on concrete human experience, physically systematically erases human experience. And even if you just look at the Bergson-Einstein debate, which is something they mention in the book, that's just not true. Einstein is not trying to erase subjectivity, and Bergson is not trying to insert subjectivity. Bergson is talking about life and embodiment as aspects of our experience of the world, and time as the irreducible, sort of almost motivational aspect of our lives that cannot be reduced to equations. But that's not reinserting anything. That's just like this, giving a description of time that is embodied at a macro scale And what Einstein was trying to do is just understand the nature of, you know, space and time, but through frames of reference and speeds. And by the way, Catherine Elgin, who I just cited, she's the one who says that beauty can play a role in epistemology as a meta principle by giving you, by telling you which of the models give you most explanations, right? So it's not just that it's beautiful, like the way the Mona Lisa is beautiful. It's playing a very important explanatory role. She says that what makes the train and lights thought experiment, the thought experiment where Einstein says there's two trains and there's people flashing the lights and then you know it.
The lights come
Okay.
back.
What she says is that what makes that thought experiment so clear and so beautiful is that it has observers and that we can relate to the act of observation as we move, right? So even if you try to understand the thought experiments that physicists are talking about, they seem to depend on subjectivity. And that's what I'm suggesting, that although the authors seem to be pointing at something interesting, once you try to see what's the positive program here, you stumble upon this problem that either there's many ways of understanding subjectivity already. If you interpret physics in a Kantian way, if you interpret physics in a mathematical Platonic way, or simply by understanding philosophy of science as, yeah, I mean, scientific models are not absolute reality, but we need to understand beauty in them, and we need to understand certain subjective categories that need to be given a explanatory gloss. And philosophers of science do that for a living. And they don't think there's a fundamental deep problem with physics.
Okay, so we have one last question.
Hi, thanks for the talk. And you mentioned Feynman in your about that commentary that maybe is from him, and probably it is from the content. And so Feynman would be someone who would say that this discussion about subjectivity doesn't matter or something like that.
Feynman would be someone, I mean, if he said this, right?
Yes.
Who was instrumental in imposing a methodology in physics that makes this possible.
So, but it's funny because I think that it's my perception is that Feynman is probably someone who was very particular about being subjective, because he inserted a lot of mathematic ways of thinking on physics and geometric ways of doing physics that some mathematics would kill him. And this is a good example for me as a subjectivity of the person working. But I think that this is something to do, not with the subjectivity thing, but I think that should be something about the structure of publications and stuff like that, because it doesn't seem that people goes to areas just because they like, but because it goes for publication. I had the subject for my PhD that we dropped it because it wasn't certain to go somewhere. It was very interesting. Then we went to something safe. And I think that this goes along the career of many scientists, not just physicists. And Feynman is also a good example of what not to do with your career, I think, because he ended his PhD and then went to work doing maps for, I don't know, the war, I think. And then he worked in the atomic bomb, and then he studied Mayan mathematics and stuff like that, and came to Rio to Carnival and spent some time. But even though he did it right, but I think that because he was not attached to these rules that come from, I know, economic views of doing publications, I think.
No, yeah, I mean, Feynman, I don't know much. I mean, one thing that is important about them is that they one person that comes up again and again as someone who has the right view is Husserl. And Husserl wrote this book that Hermann Weyl deeply admired, called The Crisis of European Sciences. And it's a book about dehumanizing knowledge, basically, that knowledge has become, you know, you could think of it as capitalized, instrumentalized, monetized, commodified, militarized. And also that humanity has lost its way, partly because we have ignored the foundational nature of our conscious awareness as the only source of justification and legitimacy for anything else. Right? So Husserl, that's his program. They seem to agree with that. And what I suggest is Husserl influenced Weyl. Weyl never thought that there was a problem at the foundation of quantum mechanics. He said, quantum mechanics is fine. It's its own thing. General relativity is fine. Yes, our understanding of space and time is filtered through our experience, but that's as far as he went. And I think what bothers some, I mean, definitely them, but other authors that think about dehumanization, is that physics in the US, nuclear physics in particular, which produced a lot of knowledge about, for example, field theory, was militarized. And people like Feynman, Einstein were deeply involved in this military effort. Again, I think that's a big problem with physics, but I don't think that's a blind spot problem. I think it's an ethical problem. And is it urgent? Yes, it is very urgent, and it's very, but people have written about it. That should be more prominent in approaches like this. Like I mentioned Bruno Latour, but there's many people in philosophy of science that have said science is supposed to be for the benefit of humanity and publicly accessible. It should lead to education and enlightenment. But that doesn't mean that we need a romantic re-enchantment of the world or just go back to the Renaissance, right? So I think Feynman is a good example because he worked in the Manhattan Project, but also because he was a very, very prolific teacher and physicist, right? And so, but I think it's better if we think of these problems as challenges facing different aspects of science, not just physics, than saying, yeah, this is a problem that physics in particular is guilty of. I mean, again, I'm speaking to the choir here, but that's for philosophical reasons. I mean, I think it's important that the ethical aspects, and the ethical aspects are going to be very difficult independently of how we think about the foundations of physics.
Carlos, oh, thank you to people who attended, you asked the questions. Thank you again. We'll be back sometime later to you again. So we have to spend more time with us.
Then I'll tell you how to solve it later.
Obrigada, Rafael. Muito obrigada.